The universe is a place of infinite wonder, but hidden within its vast expanse are mysteries that defy explanation, stories of spacecraft that vanished without a trace, leaving behind only silence and unanswered questions. Picture this: a mission launched with precision, cutting through the atmosphere with flawless execution, only to disappear into the void as if swallowed whole. No distress call, no wreckage, no logical reason, just an eerie absence that haunts the history of space exploration. These aren't tales from science fiction. They're real-life enigmas that challenge everything we think we know about the final frontier. What happens when humanity's most advanced technology simply vanishes? Some of these missions were milestones, carrying the hopes of nations and the dreams of generations. Others were humble probes sent to unlock the secrets of distant worlds, yet all share one haunting similarity: they're gone without explanation, without closure. Was it a catastrophic malfunction, a collision with an uncharted object, or something far more inexplicable lurking in the shadows of space? The truth is, even with all our advancements, the cosmos still holds cards it refuses to show. Today, we're diving deep into these unsettling disappearances, peeling back the layers of speculation and science to uncover what might have happened. From the infamous vanishing of spacecraft like NAS, a Mariner 8 to the Soviet Union's lost lunar missions, we'll explore the most compelling theories: human error, cosmic interference, even the faint possibility of forces we don't yet understand. This isn't just a story of lost machines. It's a glimpse into the fragility of our reach into the unknown. So settle in, because by the end of this journey, you might just find yourself staring at the night sky with a new sense of awe and a lingering question: what else is out there waiting to remain a mystery? The story of Cosmos 1 reads like a cosmic tragedy, a mission brimming with promise, only to vanish in the blink of an eye. Imagine a spacecraft designed to glide through the void, not on fiery rockets, but on the gentle pressure of sunlight itself. This was the dream of Cosmos 1, humanity's first attempt to prove that solar sails could revolutionize space travel. On that June day in 2005, the world watched as the Volna rocket carrying the spacecraft blasted off from a Russian submarine beneath the Barents Sea. For 83 seconds, everything went according to plan. Then silence. Tracking stations lost contact abruptly, as if the spacecraft had been plucked from existence. Initial reports suggested the rocket's engine failed, sending Cosmos 1 tumbling into the ocean. But here's where the mystery deepens. Some engineers swore they detected faint signals from the spacecraft hours later, suggesting it might have reached orbit after all. Others dismissed these as wishful thinking, echoes bouncing off the ionosphere. The truth: no debris was ever found, no definitive explanation was given. Even the submarine crew reported no signs of a failed launch, leaving theorists to wonder: did Cosmos 1 slip into some uncharted orbital graveyard, its silver sails still unfurled, silently riding beams of sunlight we can no longer track? The mission's loss was more than a technical setback. It was a blow to an entire vision of space exploration. Solar sails promised journeys to the stars without fuel, using the universe's own energy to explore further than ever before. Cosmos 1 was supposed to be the first step. Instead, its disappearance became a cautionary tale about the razor-thin margin between triumph and oblivion in space. Some speculate the sail deployed prematurely, tearing the craft apart. Others whisper about military interference, given the submarine launch's Cold War echoes. But perhaps the most haunting possibility is the simplest. space is vast and sometimes things vanish without a reason. What lingers isn't just the loss of a spacecraft, but the what-ifs. Had Cosmos 1 succeeded, we might be sailing probes toward Jupiter or Saturn on sunlight alone by now. Instead, its fate remains one of spaceflight's most poignant unanswered questions, a ghost story written in the stars, reminding us that even our boldest dreams can slip through our fingers like stardust. The race to the moon in the late 1950s was more than a scientific endeavor. It was a high-stakes duel between superpowers, where every launch carried the weight of national pride. Against this backdrop of Cold War tension, the Soviet Union's Lunik 8 probe was supposed to make history as the first spacecraft to achieve a soft landing on the lunar surface. On December 6, 1959, it streaked toward the moon with precision, its descent carefully calculated by engineers half a world away. But as it neared its destination, something went terribly wrong. Telemetry data showed the probe firing its retrorockets too early, sending it tumbling out of control. Then silence, no confirmation of impact, no signal from the surface, just an abrupt end to the mission. The official explanation pointed to a faulty gyroscope, a tiny component that doomed the entire endeavor. But decades later, the mystery only deepens. Despite multiple lunar missions mapping the surface in exquisite detail, no trace of Lunik 8 has ever been found. Not a scrap of metal, not a crater from its impact, nothing. Could the probe have shattered into dust upon hitting one of the moon's rugged highlands? Or did it vanish into one of the countless uncharted crevices that pockmark the lunar surface, swallowed by shadows? Some theorists even suggest the spacecraft might have skimmed the moon's gravity field, slingshotting into deep space, a ghost ship still wandering the cosmos. The truth is, we may never know. What makes Lunik 8's disappearance so haunting isn't just the technical failure, but the context. This was an era when every mission was a leap into the unknown, with engineers working with slide rules and guesswork, pushing boundaries without the safety nets of modern technology. The loss laid bare the brutal reality of early space exploration. For every triumph like Sputnik or Lunar 3, there were silent tragedies like Lunik 8, reminders of how thin the line was between glory and oblivion. Today, as we study the moon with satellites capable of spotting footprints left by astronauts, the absence of Lunik 8's wreckage feels almost deliberate, as if the moon itself decided to keep this secret. Perhaps that's the most fitting epitaph for a mission born in the fiery competition of the space race, not a failure, but a silent testament to the audacity of reaching for the impossible. Phobos 2's final moments remain one of the most unsettling episodes in Martian exploration, a mission that didn't just fail, but seemed to vanish under circumstances that defy easy explanation. The Soviet spacecraft had spent months circling the red planet, its cameras fixed intently on the bizarre, potato-shaped moon known as Phobos. Then, on March 28, 1989, as it prepared to deploy landers onto the moon's surface, something went terribly wrong. The last images it transmitted weren't just grainy snapshots, they were riddled with anomalies that still spark debate decades later. One photograph showed a strange, elongated shadow stretching across Phobos's barren terrain, an object that shouldn't have been there, with no identifiable source. Another frame revealed an unusual geometric pattern on the moon's surface, almost like artificial structures. Moments after these images reached Earth, Phobos 2 fell silent. No malfunction alerts, no gradual signal loss, just sudden, total radio silence. The official explanation cited a computer failure, but that didn't satisfy the skeptics. How could a state-of-the-art probe designed to withstand the rigors of deep space simply shut down at the exact moment it captured these puzzling images? Theories range from the plausible to the extraordinary. Some engineers argue that Phobos II was doomed by its own ambition. Its complex landing sequence may have overloaded its systems, triggering a fatal error. Others point to the Moon's treacherous environment, where electrostatic charges or tiny debris could have disrupted sensitive electronics. But then there are the whispers of something more unsettling. Could the shadow in that final image have been cast by something else? A clandestine satellite, perhaps, or even an artifact left by a long-vanished civilization. The wildest speculation suggests Phobos itself might not be a natural object at all, but a hollow relic of ancient engineering, a theory fueled by odd density readings and its uncanny orbit. What makes Phobos II's disappearance so haunting isn't just the loss of a spacecraft. It's the lingering sense that we were on the verge of uncovering something monumental, only to have the curtain pulled shut at the last possible moment. Even today, as newer probes map Phobos in unprecedented detail, those final images resist easy explanation. They stand as a reminder that some mysteries refuse to surrender their secrets, no matter how advanced our technology becomes. Perhaps that's the true lesson of Phobos II. In the vast, silent reaches of space, some questions are meant to remain unanswered. Mars has always been a graveyard for human ambition. While its rusty surface beckons with the promise of discovery, the planet seems to guard its secrets with an almost deliberate hostility. Take NASA Mars Observer, launched in 1992 with grand ambitions to map the entire planet in unprecedented detail. For nearly a year, the spacecraft sailed smoothly toward its destination until just 3 days before entering orbit, it vanished without a trace. No final signal, no explosion, no debris. The official investigation blamed a fuel line rupture, but even NASA engineers admitted the explanation felt incomplete. How could a billion-dollar mission, tested to withstand the rigors of space, simply go silent at the moment of triumph? Then there's the tragic case of Beagle 2, the British lander that was supposed to scour Mars for signs of life in 2003. The little probe detached from its mothership flawlessly, descending toward the surface in what should have been a textbook landing. But when the moment came to phone home, nothing. Years later, high-resolution images from another orbiter would reveal Beagle 2 intact on the surface, its solar panels only partially deployed, like a bird with clipped wings. A single stuck latch had doomed the mission, silencing its instruments before they could whisper a single word of data. These aren't isolated incidents. Over half of all missions sent to Mars have ended in failure, a statistic so grim that scientists half-jokingly refer to it as the Great Galactic Ghoul, some cosmic force that devours spacecraft. But is it really just bad luck? Mars's thin atmosphere offers little cushion for landings, while its dust storms can engulf entire continents, choking solar panels and electronics. Then there's the planet's strange magnetic anomalies, which some speculate could disrupt navigation systems at critical moments. Yet the most chilling possibility isn't environmental. It's the idea that these failures might not be random at all. Conspiracy theorists point to eerie patterns. Probes often fail during pivotal maneuvers as if something or someone doesn't want them to succeed. Could ancient Martian technology, buried for eons, still be active enough to interfere with our machines? Or is the planet itself somehow aware? Scientists dismiss such notions, but the numbers remain unsettling. What's undeniable is that Mars demands humility. Each lost mission is a reminder that space exploration isn't just about engineering, it's about confronting the unknown, where even the best plans can unravel in an instant. As we prepare to send humans to this unforgiving world, the ghosts of failed probes whisper a warning. Mars may let us visit, but it won't surrender its secrets easily. NASA Stereo B spacecraft was designed to be unshakable, a cutting-edge solar observer built to withstand the fury of the sun itself. For 8 years, it had flawlessly tracked solar storms and space weather alongside its twin, Stereo A, providing humanity with an unprecedented view of our star. But on October 1, 2014, during what should have been a routine reset, something went catastrophically wrong. The signal from Stereo B didn't just weaken or flicker, it vanished entirely, as if the spacecraft had been erased from existence. Engineers at NASA, a mission control, scrambled to re-establish contact, their screens filled with frantic lines of diagnostic code. The problem? Stereo B's systems had rebooted as planned, but its gyroscopes, the delicate instruments that keep the spacecraft oriented, failed to recalibrate. Without them, the probe began tumbling uncontrollably, its solar panels veering away from the sun. Within hours, its batteries drained, plunging the spacecraft into a silent, frozen darkness. What followed was a 22-month saga of desperation and ingenuity, as teams fired off thousands of commands into the void, hoping against hope for even a whisper of response. Theories swirled about what had triggered the blackout. Some pointed to a subtle software flaw, a single line of code that misinterpreted the gyroscope's data during the reset. Others blamed a powerful solar storm that may have scrambled Stereo B's electronics at the worst possible moment. But the most unsettling possibility was sheer bad luck, a perfect alignment of minor glitches that snowballed into disaster. Space, after all, is merciless. Even the tiniest oversight can cascade into irreversible consequences when you're floating millions of miles from Earth. Then, in August 2016, the impossible happened. A faint signal flickered across NASA's deep space network. Stereo B was alive. The relief was short-lived, though. While the spacecraft had somehow stabilized its spin, its systems were crippled, its instruments damaged beyond repair. The mission was over. What makes Stereo B's story so haunting isn't just the technical failure. It's the stark reminder that space exploration is a high-wire act without a net. Even our most advanced technology dances on the edge of oblivion, one glitch away from becoming another silent ghost in the cosmic void. This wasn't just a lost satellite. Stereo B's ordeal revealed a vulnerability no engineer had fully anticipated: the fragility of communication itself. In the vastness of space, a delay of mere seconds can mean the difference between recovery and ruin. The spacecraft's resurrection, brief as it was, offered a bittersweet lesson sometimes. Even when we pull miracles out of the darkness, the universe reminds us who's really in charge. The Soyuz 11 mission should have been a triumph, 3 cosmonauts returning home after breaking records aboard the world's first space station, Salyut-1. Instead, their descent on June 30, 1971, became one of the most chilling tragedies in space history. The capsule touched down flawlessly under its parachute, landing so gently that recovery teams initially celebrated. But when they opened the hatch, the scene inside defied comprehension. Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev sat motionless in their seats, their faces eerily peaceful, their uniforms unstained. No fire, no crash, no visible trauma, just silence. It took only minutes for the horrific truth to sink in. They'd been dead for nearly half an hour, their lives stolen not by some catastrophic failure, but by a single faulty valve no larger than a coin. The nightmare began 168 kilometers above Earth, during the routine separation of the Soyuz's orbital module from the descent capsule. A ventilation valve designed to equalize pressure during re-entry burst open prematurely. In less than a minute, the cabin's air hissed into the vacuum of space. The crew, unprotected by pressure suits, a cost-saving measure, had mere seconds to react. Transcripts later revealed their desperate attempts to locate the leak as alarms blared, their voices growing slurred as oxygen starvation set in. Dobrovolsky's final garbled transmission wasn't a mayday. It was the sound of a man struggling to form words as his brain shut down. By the time the autopilot system sealed the valve automatically, a cruel irony, it was already too late. What makes this tragedy so unsettling isn't just the technical failure, but the brutal juxtaposition of precision and fragility. The spacecraft systems performed perfectly, guiding the lifeless crew through re-entry as if nothing were wrong. Outside, the heat shield endured temperatures hot enough to melt steel. Inside, 3 men sat frozen in their seats, their bodies untouched by flames or impact, yet just as irrevocably lost. Investigators later determined they might have survived if they'd been wearing pressure suits, or if the valve had been positioned just centimeters differently. The aftermath reshaped spaceflight forever. Soviet missions suddenly included mandatory pressure suits, a practice still followed today. Engineers redesigned Soyuz valves with redundant safeguards, ensuring no single point could doom a crew. But beyond the technical fixes, Soyuz 11 forced a reckoning with space's indifference. Here was a mission where everything worked as intended except the one thing that mattered. It wasn't a rocket explosion or a botched landing that killed these men. It was the universe's quiet, mechanical cruelty, a reminder that in space, even the smallest oversight can have the loudest consequences. Their legacy lingers in every spacecraft's safety protocols, but also in something harder to define, the realization that bravery alone isn't enough against the void. The cosmonauts' names are etched on memorials, their ashes interred in the Kremlin walls, yet the most haunting tribute isn't stone or metal. It's the silent, empty descent of their perfect landing, a capsule returning exactly as planned, carrying everything except what truly mattered. Japan's Hitomi satellite was supposed to be a revolution in X-ray astronomy, a $373 million marvel capable of peering into the hearts of black holes and unraveling the violent mysteries of the cosmos. But just over a month after its February 2016 launch, this technological masterpiece tore itself apart in one of the most bizarre and costly space failures on record. The disaster began with something almost mundane, a software glitch. Hitomi's attitude control system, designed to keep the satellite perfectly steady for its ultra-precise observations, misinterpreted data from its star trackers. Convinced it was spinning wildly when it was actually stable, the onboard computer fired thrusters in a desperate attempt to correct an error that didn't exist. The violent maneuvers sent Hitomi into a real spin, one so severe that solar panels and delicate instruments began snapping off under the strain. Ground controllers watched helplessly as telemetry data spiraled into chaos. Then silence. By the time engineers stabilized communications, Hitomi was already a cloud of debris, its remnants scattered across low Earth orbit like cosmic confetti. The irony was crushing. This wasn't some experimental prototype. It was the culmination of decades of Japanese space expertise, built to outclass even NASA's finest X-ray telescopes. Yet all it took was a few lines of flawed code to reduce it to space junk. Investigators later pinpointed the fatal oversight. The software hadn't been properly tested for scenarios where the satellite's rotation sensors and gyroscopes disagreed. A simple simulation could have caught the flaw, but in the rush to meet launch deadlines, no one thought to run it. But Hitomi's legacy isn't just about a lost satellite. Its destruction added over 2,000 pieces of debris to an already cluttered orbital environment, each fragment a potential bullet traveling at 17,500 miles per hour. One chunk, later identified as part of Hitomi's solar array, passed within 200 meters of the International Space Station, forcing astronauts to prepare for emergency evacuation. This is the hidden cost of high-profile failures. Every lost mission leaves behind a minefield for future spacecraft. The tragedy forced space agencies worldwide to confront an uncomfortable truth. As our orbital infrastructure grows more complex, so do the risks of cascading failures. A single software bug can now trigger disasters with consequences far beyond one mission. Hitomi's story isn't just a cautionary tale about coding. It's a stark reminder that in space, there's no such thing as an isolated mistake. Every error ripples outward, sometimes long after the mission itself is gone. What lingers isn't just the ghost of a $373 million satellite, but the uneasy question: in our rush to unlock the universe's secrets, are we building traps for ourselves among the stars? India's Chandrayaan-2 mission was poised to make history, not just for its ambitious lunar landing attempt, but for the agonizing mystery that unfolded in its final moments. The Vikram lander, named after the father of India's space program, Vikram Sarabhai, descended toward the moon's south pole on September 6, 2019, with the precision of a carefully choreographed dance. Millions watched live as telemetry data streamed in, the tension thickening with each passing second. Then, at just 2.1 kilometers above the surface, close enough to see the dust kicked up by its thrusters, Vikram vanished from mission control screens. The silence that followed wasn't just the absence of signal. It was the sound of a nation's collective breath held too long. What makes Vikram's disappearance so haunting isn't just the technical failure. It's the razor-thin margin between triumph and tragedy. Later analysis revealed the lander had been descending too fast, its velocity nearly 3 times higher than intended during those critical final seconds. Engineers would later pinpoint a cascade of errors, a minor software glitch that overcorrected the lander's trajectory, combined with the unexpected roughness of the landing site. The moon's south pole, with its permanently shadowed craters and jagged terrain, proved far more treacherous than simulations had predicted. But here's where the mystery deepens when NASA, a lunar reconnaissance orbiter, scanned the area weeks later. It spotted debris scattered across the impact site, yet Vikram itself was nowhere to be found. Theories about what went wrong split into 2 camps. Some argue that Vikram's inertial measurement unit, the device tracking its orientation, became confused by the lander's sudden maneuvers, sending erratic data to the guidance system. Others point to the moon's uneven gravity field, which can subtly distort a spacecraft's path in ways even advanced algorithms struggle to predict. But the most unsettling possibility is that Vikram didn't crash at all, that it might have bounced. The lander's design included shock-absorbing legs capable of surviving a rough touchdown, leading to speculation that Vikram could have skidded across the surface, coming to rest in one of the region's pitch-black craters where sunlight and communication never reaches. The aftermath of Vikram's loss revealed something unexpected. The failure became a catalyst for innovation. India's space agency, ISRO, didn't retreat from lunar exploration, it doubled down. Engineers pored over every byte of descent data, uncovering flaws in the mission's autonomous hazard detection system. These hard-won lessons directly influenced Chandrayaan-3, which would later stick its landing with flawless precision. But Vikram's legacy isn't just about improved technology, it's a testament to the brutal honesty of space. The moon doesn't care about national pride or scientific ambition. It demands perfection, and even then, it offers no guarantees. Perhaps that's why Vikram's story resonates so deeply. It's not just a tale of a lost lander, but a reminder that exploration is as much about humility as it is about discovery. Every crater on the moon holds shadows, both literal and metaphorical, and sometimes the most profound lessons come from the missions that vanish into them. The launch of SpaceX's Falcon 9 rocket in January 2018 should have been routine, another flawless delivery for Elon Musk's aerospace juggernaut. But the payload it carried, a mysterious satellite known only as Zuma, would become one of modern spaceflight's most tantalizing enigmas. Officially, the mission ended in failure. Reports claimed the billion-dollar classified satellite, built by defense contractor Northrop Grumman for an undisclosed U.S. government agency, never made it to orbit. SpaceX insisted their rocket performed flawlessly, pointing instead to a suspected malfunction with the payload adapter, the crucial interface between satellite and rocket. Yet from the moment those conflicting narratives emerged, speculation spiraled into overdrive. Was Zuma really lost, or had it vanished into the shadows by design? What makes this case so fascinating isn't just the technical uncertainty, it's the eerie lack of evidence. Most failed missions leave breadcrumbs, debris fields, erratic telemetry, or at least a paper trail of investigations. Zuma left nothing. No wreckage was ever recovered. No government agency claimed ownership or demanded compensation. Even more puzzling, amateur satellite trackers noticed unusual activity in the weeks after the launch, unidentified objects in orbits matching Zuma's intended trajectory. Could the satellite have deployed secretly after all, its failure merely a smokescreen? Theorists pounced on inconsistencies. SpaceX had never before or since blamed a payload adapter for a mission loss. And Northrop Grumman's silence was deafening. The company never released findings from its internal review. The cloak and dagger possibilities are straight out of a spy thriller. Some analysts suggest Zuma was an advanced stealth reconnaissance satellite designed to monitor rival powers with next-gen surveillance tech. Its alleged destruction might have been a ruse to conceal its true purpose or even its survival. Others propose darker scenarios, a deliberate sacrifice to test anti-satellite weaponry under the guise of an accident. Even the timing raised eyebrows. The launch occurred just as tensions over space militarization were escalating globally. Coincidence or calculated misdirection? What's undeniable is how Zuma exposes the double-edged sword of secrecy in space. While national security demands discretion, excessive classification can breed mistrust and confusion. When missions vanish into bureaucratic fog, the public is left guessing, and conspiracy theories flourish. SpaceX's reputation took a temporary hit despite their protests, proving that in the court of public opinion, ambiguity often looks like guilt. Yet perhaps the most revealing detail emerged years later, buried in a Pentagon budget document, a cryptic line item referencing Zuma-derived operational capabilities. The wording was vague, but the implication was clear. Someone, somewhere, had learned something valuable from that fateful night. Zuma's legacy isn't just about a single satellite's fate. It's a case study in how modern spaceflight operates at the intersection of technology and intrigue, where the truth might forever hover just beyond reach. In an era when rockets launch weekly and satellites outnumber stars in some orbital lanes, we're reminded that not all progress happens in the light. Some missions slip into the shadows by accident and others, perhaps by design. The European Space Agency's Skyaparelli lander was supposed to mark Europe's triumphant arrival on Mars, a meticulously planned descent that would prove the continent's capability to explore the Red Planet. But on October 19, 2016, what began as a textbook landing sequence spiraled into catastrophe in a matter of seconds. Skyaparelli's final moments were a masterclass in how the smallest oversight can unravel even the most sophisticated mission. As the lander streaked through Mars' thin atmosphere, its inertial measurement unit, the system tracking its rotation, became saturated, overwhelmed by data during the violent turbulence of entry. For just 1 second, the computer misinterpreted its own altitude, believing it had already touched down when it was still 3.7 kilometers above the surface. That single second of confusion triggered a chain reaction. The lander's parachute jettisoned prematurely. Its braking thrusters fired for only 3 seconds instead of the planned 30. Skyaparelli plummeted like a stone, slamming into Mars at over 300 kilometers per hour. The impact site, later photographed by NASA Mars Reconnaissance Orbiter, told the grim story, a dark scar in the Martian dust, surrounded by debris scattered like confetti. Yet the most haunting detail, Skyaparelli's computer kept transmitting data all the way down, blissfully unaware of its impending doom, its final signal cutting off abruptly at the moment of impact. What makes this failure so unsettling isn't just the technical flaw, it's how eerily close it came to success. The lander's heat shield, parachute, and navigation systems all performed flawlessly until that critical sensor glitch. Engineers later determined the crash could have been avoided with a simple software patch, a few lines of code to prevent the system from misreading its own data. But space offers no second chances. Skyaparelli's fate mirrors a paradox of modern exploration. Our missions are more advanced than ever, yet they still dance on the edge of disaster, where a single line of faulty logic can erase years of planning. The aftermath revealed an even deeper lesson. Skyaparelli wasn't just a lander, it was a test run for ExoMars, Europe's ambitious rover mission. Its failure, painful as it was, exposed vulnerabilities that might have doomed the far more expensive rover. Engineers redesigned systems, added redundancies, and most crucially, learned to distrust their own sensors. Sometimes, the most valuable discoveries aren't made on distant worlds, but in the wreckage of our own mistakes. Skyaparelli's legacy isn't just a crater on Mars. It's a reminder that in space exploration, progress is often measured in hard lessons, written not in triumphs, but in the silence of lost signals. NASA Image satellite was pronounced dead in December 2005, a casualty of what engineers believed was an irreparable power failure. For 13 long years, it drifted silently through Earth's magnetosphere, a ghostly relic of a mission once celebrated for revolutionizing our understanding of space weather. Then, on an unremarkable January day in 2018, something impossible happened. An amateur astronomer in Canada picked up a faint signal, one that matched Image's long-dormant transmission frequency. At first, NASA dismissed it as an error, but when the signals persisted, the truth became undeniable. Image had woken up. How does a spacecraft declared dead suddenly come back to life? The theories range from the scientifically plausible to the borderline surreal. Some engineers speculate that Image batteries, frozen solid in the depths of space, somehow thawed as the satellite's orbit brought it closer to the Sun, allowing a trickle of power to revive its systems. Others point to a cosmic reset, a high-energy particle strike that may have jolted the onboard computer out of its failure mode, effectively rebooting it by accident. Then there's the wild-card possibility. Could an unknown force, some quirk of space physics we don't yet understand, have intervened? What makes Image resurrection so extraordinary isn't just the mystery of its revival, it's the implications. This wasn't just any satellite. Image was designed to study Earth's invisible magnetic bubble, the magnetosphere, capturing the first global images of the dynamic forces that shield our planet from solar storms. Its sudden return offered a tantalizing opportunity, 13 years of unrecorded data, a treasure trove of insights into how our planet's defenses had evolved over time. But there was a catch. NASA ground systems had long since been upgraded, rendering the old communication protocols obsolete. Engineers scrambled to dust off decades-old software, piecing together forgotten code like archaeologists deciphering an ancient language. For a brief, exhilarating window, Image whispered its secrets back to Earth. Then, just as mysteriously as it had revived, the satellite fell silent again in 2019. Was its second death final this time, or could another cosmic fluke bring it back once more? Image story forces us to confront the uncomfortable truth that space is far less predictable than we'd like to believe. Our satellites are built with meticulous care, tested against every conceivable failure, yet sometimes the universe reminds us that it writes its own rules. Perhaps the most haunting lesson isn't about technology at all. Image ordeal mirrors the very phenomena it was sent to study, the magnetosphere's chaotic, unpredictable nature. Just as solar winds can twist Earth's magnetic field into sudden turmoil, space itself seems to operate on a logic we're only beginning to grasp. Missions like Image don't just map the unknown, they reveal how much we still have to learn. And sometimes they come back from the dead to tell us. The story of Apollo 10's lunar module Snoopy isn't just a footnote in space history, it's one of the solar system's greatest unsolved hide-and-seek games. After completing its dress rehearsal for the first moon landing in May 1969, the spidery spacecraft was jettisoned into orbit around the Sun, a deliberate move to clear the way for Apollo 11's historic mission. NASA assumed Snoopy would vanish into the void, just another piece of space debris. But here's the twist: no one actually knows where it is today. For decades, astronomers considered Snoopy lost forever, drifting somewhere in the vast expanse between Earth and the Sun. Then, in 2011, a team of British enthusiasts launched the Snoopy project, combing through radar data and orbital calculations in hopes of spotting the long-lost module. Their reasoning was simple: if we can track asteroids the size of refrigerators, why not a spacecraft as large as a small car? The challenge, though, is staggering. Snoopy's trajectory was never precisely mapped after separation, and sunlight reflecting off its metal surface could send it tumbling unpredictably. Worse yet, it might have been nudged off course by gravitational tugs from planets over the decades, turning its path into a cosmic pinball game. But why does finding Snoopy matter beyond nostalgia? This isn't just about recovering a relic, it's about unlocking secrets of space navigation. The module's movements, if traced, could reveal subtle gravitational quirks in the inner solar system, the kind of forces that subtly alter spacecraft trajectories in ways we still don't fully understand. Some scientists speculate Snoopy might even be caught in a strange orbital resonance with Earth, looping around the Sun in sync with our planet's own orbit. If true, it could teach us how objects interact in chaotic gravitational dances over time. The search took an eerie turn in 2019 when a team at the European Space Agency tentatively identified an object near Earth's orbit as possibly being Snoopy. Excitement flared until closer analysis showed the candidate was just another asteroid. Yet the hunt continues, fueled by modern telescopes and machine learning algorithms that sift through sky surveys for anomalies. There's a poetic symmetry to the quest. The same module that helped pave the way for humanity's greatest adventure now drifts as a silent witness to how much we still have to learn. Perhaps the most haunting possibility is that Snoopy isn't lost at all, just overlooked. Space is cluttered with debris, and distinguishing a 50-year-old spacecraft from asteroids requires painstaking detective work. Every time astronomers rule out another candidate, the mystery deepens. What if Snoopy's out there right now, tumbling through sunlight, its metallic skin pockmarked by micrometeorites, waiting for someone to piece together its celestial breadcrumbs? Until then, it remains a ghost of the space age, a reminder that even our most carefully planned missions can slip into the unknown. And that's the real lesson here. In space, sometimes the most fascinating discoveries aren't what we send out, but what somehow finds its way back into the story. Russia's Phobos-Grunt mission was supposed to be a redemption story, a bold return to interplanetary exploration after decades of setbacks. Instead, it became a spectacle of humiliation, a $265 million spacecraft that couldn't even escape Earth's embrace. Launched on November 9, 2011, the probe roared into the sky atop a Zenit rocket, carrying dreams of scooping soil from Mars' enigmatic moon Phobos. But within hours, it was clear something had gone terribly wrong. Phobos-Grunt's engines failed to ignite, stranding it in low Earth orbit like a car stuck in neutral on a highway. For weeks, the world watched as the doomed spacecraft tumbled helplessly, its solar panels glinting in the sunlight like distress signals. Then, on January 15, 2012, gravity finally claimed its prize. Phobos-Grunt burned up over the Pacific Ocean, scattering debris and unanswered questions. What makes this failure so perplexing isn't just the technical malfunction, it's the cloud of suspicion that still lingers. Almost immediately, whispers of sabotage emerged from Russian space officials. Some pointed fingers at American radar systems, suggesting powerful electromagnetic pulses from Alaska might have scrambled the probe's electronics. Others hinted at cyber sabotage, a digital assassination in the shadowy realm of space espionage. But the most compelling evidence points to something far more mundane, a perfect storm of engineering complacency and bad luck. Investigators later discovered the spacecraft's flight computer had been programmed with outdated star charts, causing its navigation system to reject valid commands. Meanwhile, the propulsion system, a complex web of valves and pipes, suffered from poor quality control, with some components failing under stress tests before launch. Then there was the terrifying footnote. Phobos-Grunt's fuel tanks were loaded with 22 tons of toxic hydrazine and nitrogen tetroxide, a corrosive cocktail capable of poisoning entire regions if it survived re-entry. As the probe's orbit decayed, nations from Kazakhstan to Australia braced for potential environmental disaster. In the end, the fuel burned harmlessly in the upper atmosphere, but the incident exposed a chilling blind spot in space safety protocols. No one had seriously considered what might happen if an interplanetary probe, packed with enough poison to wipe out a city, got trapped in Earth's backyard. The true tragedy of Phobos-Grunt lies in its missed opportunities. Had its engines fired correctly, it might have unlocked secrets about Phobos' origins, whether it's a captured asteroid or a chunk of Mars itself. Instead, the mission became a cautionary tale about how easily ambition can unravel. Space doesn't just punish mistakes, it magnifies them, turning tiny oversights into catastrophic failures. For Russia, the loss was more than financial. It was a blow to national pride, a stark reminder that in the high-stakes game of space exploration, Earth's gravity isn't the only force working against you. Sometimes the greatest obstacles aren't out there among the stars, but in the flawed human systems that try to reach them. Phobos-Grunt's legacy isn't just a fiery re-entry or conspiracy theories, it's a lesson in humility. Even with all our technology, space remains a realm where the smallest oversight can chain a billion-dollar mission to Earth's orbit, a prisoner of gravity's unrelenting grip. And perhaps that's the hardest truth of all. The cosmos doesn't care about our plans, it only cares about physics. China's Long March 5B rocket wasn't supposed to become a global menace, but in May 2021, that's exactly what happened. The massive core stage, weighing nearly 23 tons, had delivered part of China's new space station into orbit. Then, instead of following standard procedure by steering itself into a controlled re-entry over uninhabited ocean, the booster began tumbling unpredictably, its descent governed solely by the whims of atmospheric drag. For over a week, the world watched nervously as orbital tracking maps projected its potential impact zone, a shifting shadow that crept across continents from New York to Jakarta. No one could say where or when it would strike. When the debris finally plunged into the Indian Ocean near the Maldives, the relief was palpable, but the implications lingered like a warning shot across the bow of space exploration. What made this incident so alarming wasn't just the size of the rogue rocket stage, it was the precedent it set. Space agencies have long adhered to unofficial, best practices for disposing of spent hardware, ensuring it burns up safely or splashes down far from populated areas. China's decision to forego these safeguards exposed a chilling reality. In the rush to dominate the new space race, some nations are playing by their own rules. The Long March 5B's freefall wasn't an isolated mishap. It was the fourth time in 2 years that China allowed a massive rocket stage to crash uncontrolled. Each event ratcheted up global tension, with NASA administrators publicly condemning the recklessness, while astronomers scrambled to predict impact zones with agonizing uncertainty. The risks extend far beyond a single rogue rocket. Earth's orbit is already cluttered with over 27,000 tracked pieces of debris larger than a softball, all hurtling at speeds faster than bullets. A collision with even a small fragment could cripple satellites, puncture the International Space Station, or, in a worst-case scenario, trigger the Kessler syndrome, a catastrophic chain reaction where cascading debris renders entire orbital altitudes unusable for generations. The Long March 5B incident was a stark reminder that vanishing missions don't always disappear harmlessly. Sometimes they come back with a vengeance. Yet the most unsettling part of this saga isn't the technology, it's the accountability gap. Unlike maritime or aviation laws, which hold nations responsible for hazards they create, space debris regulation remains a gray zone. The Outer Space Treaty of 1967 is toothless on enforcement, and no international body has authority to penalize reckless launches. China's response to criticism. A shrug, state media dismissed concerns as Western hype, while engineers quietly adjusted designs for future rockets, but offered no apologies for the close calls. This isn't just about one nation's choices. As private companies and emerging space powers flood the cosmos with satellites and stations, the Long March 5B debacle serves as a wake-up call. Space is becoming a wild west where the stakes aren't just scientific glory or national prestige. They're the safety of every person on Earth. The next rogue re-entry might not splash down harmlessly. It could slam into a city, igniting not just debris, but diplomatic fires we're woefully unprepared to extinguish. The lesson is clear: in space, what goes up must come down. The question is whether we'll act before the consequences come down on us. Pioneer 10 was never meant to be silent. Launched in 1972 as humanity's first emissary to the outer solar system, this plucky probe defied expectations at every turn, slipping through the asteroid belt unscathed, capturing the first close-ups of Jupiter, and proving we could reach beyond Mars. For 31 years, its faint radio whispers traveled back to Earth, each signal weaker than the last as its nuclear power source decayed. Then, in January 2003, NASA, a deep space network, listened for the usual heartbeat from 11 billion kilometers away and heard nothing. Just cosmic static, no final malfunction, no dramatic last words, just the quietest of goodbyes. Tracking Pioneer 10 now is like searching for a needle in a galaxy-sized haystack. Unlike objects in Earth's orbit, deep space probes drift without fixed reference points, their positions calculated through complex models of solar gravity and radiation pressure. Even a slight error compounds over decades. Pioneer 10's current location could be off by millions of kilometers in official estimates. The probe's trajectory, aimed roughly toward the red star Aldebaran, won't bring it close to another celestial body for over 2 million years. By then, its golden plaque engraved with a message for any hypothetical finders will likely be eroded to dust by micrometeorites, leaving no trace of its earthly origins. There's something deeply poetic about Pioneer 10's fate. This spacecraft, which carried humanity's first deliberate attempt to communicate with extraterrestrial intelligence, now floats mutely through the void, its technology frozen in time. Its 8-track tape recorder and 70-kilobyte computer memory seem laughably primitive today, yet they represent the spark that ignited our interstellar ambitions. The silence isn't just technical, it's symbolic. Every deep space mission faces this inevitable fade out as power dwindles and antennas lose alignment. Voyager 1 and 2 will follow, New Horizons 2, all destined to become ghost ships, their scientific legacies preserved only in Earth's archives while their physical forms vanish into the dark. Yet perhaps the most haunting detail lies in what Pioneer 10 still carries. That iconic plaque, designed by Carl Sagan and Frank Drake, depicts a man and woman alongside a cosmic roadmap to Earth. It's a message that assumes someone someday might care to look, but with the probe now untrackable even by our most powerful telescopes, it's entirely possible that plaque will never be seen again, a bottled letter cast into an ocean so vast it might as well be imaginary. Pioneer 10's true legacy isn't just the date it sent home, but the uncomfortable truth it reveals. Space doesn't just swallow our probes. Given enough time, it swallows our stories too. The next time you gaze at the night sky, consider this. Out there, beyond Neptune, beyond Pluto, in some unknowable patch of blackness, a silent ambassador from 1972 drifts unseen. Its mission long over, its inventors mostly passed on, its very existence fading from cultural memory. Space exploration often feels like a chain of triumphs, but Pioneer 10 reminds us it's also a graveyard of quiet endings, where even our greatest achievements eventually become whispers, then echoes, then nothing at all. Israel's Bereshit lander wasn't just a spacecraft, it was a symbol of audacious ambition, a testament to what happens when a tiny nation and a scrappy startup dare to reach for the moon. On April 11, 2019, the world watched as this privately funded probe, built by the non-profit Space IL for a fraction of NASA's typical budgets, descended toward the lunar surface. For a few breathless minutes, it seemed the impossible might happen. Israel would become the 4th country to land softly on the moon. Then, with cruel abruptness, the dream unraveled. Telemetry showed the main engine cutting out at the worst possible moment, just 150 meters above the surface. Engineers frantically reset systems as Bereshit plummeted, its cameras still transmitting haunting final frames of the moon's craters rushing up to meet it. The impact was violent, scattering debris across the Sea of Serenity. But the real shockwave was the realization that space shows no mercy, even to the boldest pioneers. What makes Bereshit's failure so gut-wrenching isn't just the technical mishap, it's the razor-thin margin between triumph and disaster. Post-crash analysis revealed a cascade of tiny errors. A faulty inertial measurement unit caused the spacecraft to spin slightly during descent, triggering an automatic reset of the main computer. During those critical seconds of reboot, the engine shut down entirely. By the time ground control restored communication, Bereshit was falling too fast to recover. The cruel irony, the engine failure wasn't a design flaw. It was a software glitch, a few lines of code that didn't account for the chaos of real-time lunar descent. Space IL's engineers had prioritized innovation over redundancy, betting on lean, agile systems rather than the conservative backups favored by government agencies. In any other industry, that gamble might have paid off, But space demands perfection. Bereshit's story exposes the unique perils of private space ventures. Unlike NASA or ESA missions, which benefit from decades of institutional knowledge and near unlimited testing, startups operate on shoestring budgets and relentless deadlines. Every dollar saved is a risk calculated, every shortcut a potential trapdoor. SpaceIL's team worked miracles building a lunar lander for just $100 million, a fraction of what superpowers spend, but in space, miracles aren't enough. The moon doesn't care about your funding gaps or your inspirational backstory. It only cares about physics, yet there's an unexpected twist to this tragedy. Bereshit's wreckage may have inadvertently created a new kind of lunar mystery. Among the debris was a peculiar payload, thousands of microscopic tardigrades, those nearly indestructible water bears capable of surviving the vacuum of space. Whether they endured the crash remains unknown, but if even a handful survived, scattered in the moon's regolith, they'd be the hardiest life forms ever left on another world. A bizarre footnote to a mission that epitomizes both the promise and peril of private spaceflight. The legacy of Bereshit isn't just a crater on the moon, it's a wake-up call. As more startups race to the stars, lured by cheaper technology and billionaire backers, they do well to remember this lesson. Space forgives no shortcuts. Every failed sensor, every untested line of code, every optimistic assumption can become a tombstone. But here's the paradox: without these daring underdogs, without the willingness to fail spectacularly, exploration stagnates. Bereshit's wreckage isn't just debris. It's a marker on the long, rocky road to making space accessible to everyone. And perhaps that's the most haunting truth of all. Progress in the cosmos isn't measured just by the missions that succeed, but by those that vanish into the dust, teaching us how to do better next time. NASA Mars Polar Lander should have been a celebration of human ingenuity, a daring attempt to touch down near the red planet's frozen southern pole, where layers of water ice and dust might reveal secrets of Mars' ancient climate. Instead, its final moments on December 3, 1999, became one of the most frustrating mysteries in planetary exploration. The spacecraft descended through the thin Martian atmosphere flawlessly, its parachute deploying right on schedule. Then, at an altitude of just 40 meters, so close to the surface that dust would have been visible in its cameras, the signal vanished. No crash, no explosion, no last-second telemetry hinting at disaster. Just silence. The investigation that followed was a masterclass in scientific heartbreak. Without wreckage to examine or final data transmissions to analyze, engineers were left to reconstruct the failure like detectives solving a crime with no body. The leading theory, a catastrophic software glitch. As the lander's legs deployed during descent, sensors in the landing gear were supposed to detect touchdown and immediately shut down the engines to prevent tipping. But in a cruel twist of programming, these sensors could also generate false signals during deployment, phantom touches that tricked the computer into thinking it had already landed while still high in the air. If this happened, the engines would have cut out prematurely, sending the $800 million spacecraft plummeting to destruction. What makes this failure so haunting isn't just the technical oversight, it's how preventable it was. Testing later proved that a simple software patch could have ignored those false signals, but in the rush to meet launch deadlines, no one thought to simulate this exact scenario. The bitter irony: Mars Polar Lander's identical twin, Mars Climate Orbiter, had burned up in the planet's atmosphere just months earlier due to another absurdly simple error, a mix-up between metric and imperial units. Together, these back-to-back failures forced NASA to confront uncomfortable truths about complacency. The agency had become so confident in its Mars expertise after the triumphant Pathfinder mission that it skipped crucial safeguards, treating interplanetary travel as routine when it's anything but. The legacy of Mars Polar Lander lives on in every Mars mission since. NASA instituted sweeping reforms from faster, better, cheaper program overhauls to mandatory blackout periods where no critical commands can be sent during landing. Engineers now obsess over failure modes that once seemed improbable, running thousands of simulations to catch glitches before they reach space, perhaps the most poignant change. Modern landers like Insight and Perseverance don't just rely on leg sensors, they use radar, cameras, and inertial measurements to cross-check their altitude, ensuring no single point of failure can doom them. Yet for all the lessons learned, Mars Polar Lander's disappearance remains an open wound. Unlike other lost missions, there's no crater to visit, no debris field to study, just the lingering question of what might have been. Had it succeeded, we might have unlocked Mars' climate history decades earlier, understanding its transition from wet world to frozen desert. Instead, its silent fate stands as a monument to humility. Space exploration doesn't tolerate shortcuts. Every mission is a high-wire act where the smallest oversight, a line of code, a unit conversion, a sensor unchecked, can erase years of work in an instant. The Red Planet doesn't care about our intentions, only our execution. And sometimes the loudest lessons come from missions that never get to speak at all. The night of February 21, 1958, crackled with mystery when Italian radio enthusiasts monitoring Soviet space transmissions made an unsettling discovery. Amid the static, they captured a woman's voice, weak, labored breaths punctuated by erratic heartbeats before the signal dissolved into silence. Official records claimed no Soviet launches that day. Yet the recording, later dubbed the Judica Cordiglia brothers tapes, fueled one of spaceflight's most enduring conspiracies, the legend of lost cosmonauts, men and women who allegedly vanished into the void, their fates buried beneath layers of Cold War secrecy. This wasn't an isolated incident. Over the next decade, amateur radio operators across Europe reported intercepting distress calls from orbit pleas for help in Russian, sometimes accompanied by the hiss of escaping air. The most chilling, a 1961 transmission where a cosmonaut's voice, trembling with desperation, repeated, "This is bad, everything is bad," as his spacecraft burned up during re-entry. Soviet authorities dismissed these as hoaxes or misidentified signals, but the timing was suspicious. Many intercepts coincided with periods when the USSR was known to be testing space capsules, yet no corresponding missions were acknowledged. Why would a spacefaring nation hide fatalities? The answer lies in the brutal politics of the space race. Every launch was propaganda, proof of ideological superiority. Admitting failure risked humiliation, especially after Yuri Gagarin's triumph in 1961, made the Soviet Union seem invincible. Declassified documents later revealed a darker truth. The Soviet space program was far deadlier than publicly admitted. Engineers worked under crushing pressure, cutting corners to meet impossible deadlines. Prototype spacecraft often launched without escape systems, and cosmonauts boarded untested vehicles knowing they might not return. The most compelling evidence for lost cosmonauts emerged not from radio static, but from the cosmos itself. In 1963, two female cosmonauts, Valentina Tereshkova and an alleged backup, Ludmila Tokavi, were photographed during training. Only Tereshkova flew. Tokavi vanished from records. Similarly, a 1960 photo showed a group of cosmonaut candidates. By 1962, 3 were scrubbed from official rosters without explanation. Were these purged trainees or casualties of missions gone wrong? Even Gagarin himself hinted at the cost, reportedly telling colleagues, "Let's pray for those who fly before us and after us." But skepticism persists. Without physical evidence, no wreckage, no graves, no declassified mission logs, the lost cosmonaut theory remains in limbo. Some argue the radio intercepts were misidentified test transmissions or even psychological warfare by Western intelligence. Others point to simpler explanations: the USSR's habit of scrubbing missions mid-flight due to technical glitches, leaving cosmonauts grounded but alive. What makes these stories linger isn't just the mystery, it's what they reveal about the human cost of exploration. Every spacefaring nation has tragedies it would rather forget. NASA Apollo 1 fire, China's unreported early launch failures. The Soviet Union's potential losses are unique only in their opacity. Secrecy, as it turns out, is the perfect breeding ground for myths. When facts are buried, speculation rushes in to fill the void. Perhaps the truth lies somewhere between conspiracy and cautionary tale. Space has always demanded sacrifice, and not all of it is recorded. The lost cosmonauts, real or imagined, serve as ghostly reminders of an era when progress was measured in blood as much as bravery. Their whispers from the void ask us an uncomfortable question. In our rush to conquer the stars, how many names have we left behind? The answer, like those faint radio signals, may forever drift just beyond our reach. The launch of Vanguard TV3 was supposed to be America's triumphant answer to Sputnik, a sleek, scientific satellite that would prove the United States could compete in the space race. Instead, on December 6, 1957, it became one of the most public and humiliating failures in aerospace history. Millions watched live as the slender rocket rose just 4 feet off the pad at Cape Canaveral before shuddering violently, its engine losing thrust. For a heart-stopping moment, it hovered there, as if suspended in disbelief. Then, with a deafening roar, it collapsed back onto itself in a fireball so intense it vaporized the satellite instantly, leaving only twisted metal and a towering plume of black smoke. The press didn't hesitate. Headlines worldwide mocked the spectacle, dubbing it Flopnik and Kaputnik, while Soviet newspapers gleefully framed it as proof of American technological inferiority. Behind the scenes, the disaster was even more devastating. Vanguard TV3 wasn't just any satellite, it was the crown jewel of Project Vanguard, a civilian-led initiative meant to showcase peaceful scientific exploration, distinct from military missile programs. Its destruction laid bare the rushed, underfunded reality of America's early space efforts. Engineers had warned about untested components and the rocket's fragile design, but Cold War pressures forced the launch ahead of schedule. The explosion wasn't an accident. It was the inevitable result of a system prioritizing speed over precision. Yet from the ashes of that failure came an unexpected turning point. The very public nature of Vanguard's demise shocked Washington into action. Politicians who had dismissed space exploration as a sideshow suddenly demanded answers and funding. Within months, Congress passed the National Aeronautics and Space Act, birthing NASA and consolidating the chaotic patchwork of competing programs under one agency. The lessons of Vanguard TV3 became the foundation of a new approach: meticulous testing, rigorous quality control, and a culture that valued transparency over secrecy. Ironically, the satellite itself would have a second act. Engineers salvaged spare components to build Vanguard 1, which launched successfully in 1958. Today, it's the oldest human-made object still in orbit, a silent testament to resilience. The fiery failure of its predecessor wasn't the end of America's space ambitions. It was the spark that forced a reckoning, proving that sometimes the road to the stars begins with an explosion on the ground. The laughter of 1957 didn't last long. Within a year, the United States would launch Explorer 1, and the space race would shift forever. But none of it would have happened without the hard lessons learned from that very public vanishing. Japan's Nozomi probe was supposed to be a symbol of national pride, the country's first successful mission to Mars, designed to study the planet's atmosphere and magnetic field. But from the moment it launched on July 4, 1998, it seemed the universe had other plans. The spacecraft's name, which means hope in Japanese, would soon feel painfully ironic as Nozomi endured what can only be described as a cosmic gauntlet of misfortune. The first disaster struck just months into the journey. A critical engine burn went wrong, leaving Nozomi with too little fuel to follow its planned trajectory. Engineers scrambled to improvise a new path, a longer, looping route that would take 4 extra years to reach Mars, but space isn't forgiving of delays. In April 2002, a massive solar flare bombarded the probe, frying its electronics and crippling its communication systems. Imagine a ship caught in a hurricane, its sails torn, its compass shattered. Nozomi was left drifting, barely responsive, its signals flickering like a dying candle. Yet the worst was still to come. As the battered spacecraft finally neared Mars in December 2003, another fuel leak sent it spinning out of control. Ground teams fought desperately to stabilize it, but the damage was too severe. Nozomi missed its orbital insertion by a heartbreaking margin, sailing past the red planet into the void of deep space. The probe that had survived solar storms, fuel shortages, and years of uncertainty was now destined to wander the solar system endlessly, a ghost ship with no destination. What makes Nozomi's story so haunting isn't just the string of bad luck, it's the chilling possibility that some missions are cursed from the start. Every space agency has tales of doomed projects, but Nozomi's litany of disasters feels almost deliberate, as if Mars itself were pushing it away. Some engineers whisper about the Mars curse, noting how many probes have failed there, nearly half of all attempts. Others point to more practical explanations, the unforgiving math of orbital mechanics, the brutal radiation environment between Earth and Mars, the sheer complexity of interplanetary travel. But perhaps the most unsettling lesson lies in what Nozomi's ordeal reveals about our place in the cosmos. Space doesn't care about human ambition. It doesn't distinguish between a billion-dollar mission and a student-built satellite. The same forces that sculpt galaxies and birth stars will just as easily derail our fragile machines without a second thought. Nozomi wasn't sabotaged by some cosmic malice. It was simply another reminder that the universe plays by its own rules, indifferent to our hopes and plans. Today, Nozomi's silent signal continues somewhere beyond Mars, its instruments long dead, its power depleted. It's not alone. Countless other lost probes drift through the dark, their stories untold. But there's a strange beauty in its persistence. Even as a derelict, Nozomi is still out there, still moving, still carrying the faintest echo of human curiosity into the unknown. And maybe that's the real legacy of these vanishing missions, not the data they failed to send back, but the quiet proof that sometimes simply reaching for the stars, no matter the outcome, is its own kind of triumph. Deep beneath the skies of the South Atlantic, an invisible force wreaks havoc on our machines, a sprawling zone where Earth's magnetic field weakens like a frayed shield, exposing anything that passes to a torrent of cosmic radiation. This is the South Atlantic Anomaly, often called the Bermuda Triangle of space, a region where satellites stutter, instruments glitch, and some spacecraft vanish without explanation. Unlike the mythical mysteries of its ocean counterpart, the dangers here are very real, measured in scrambled data and unexplained failures. Radiation levels spike so high that astronauts aboard the International Space Station report seeing flashes of light behind their closed eyelids as charged particles tear through their retinas. If that's what happens to shielded humans, imagine what it does to delicate electronics. The anomaly's origins trace back to Earth's molten core, where turbulent flows of liquid iron generate our planet's magnetic field. But deep beneath South America and the southern Atlantic, this field dips unsettlingly close to the surface, creating a funnel where deadly particles from the Van Allen radiation belts normally held at bay come raining down. Spacecraft passing through this zone endure a merciless bombardment. Hubble telescope engineers routinely shut down its instruments here to avoid damage. The Chandra X-ray Observatory goes blind for hours at a time, and some missions never recover at all. Take, for instance, NAS, a swift satellite designed to study gamma-ray bursts. In 2011, it entered the anomaly and emerged with its star trackers critical for navigation fried beyond repair. Engineers managed a workaround, but others weren't so lucky. Rumors persist of classified military satellites losing contact permanently in the region, their fate buried under layers of national security secrecy. Even the European Space Agency's cluster mission, a quartet of hardy probes studying Earth's magnetosphere, recorded unexplained attitude disturbances while traversing the zone as if unseen hands were nudging them off course. Could the anomaly explain some of space's most puzzling disappearances? It's tempting to connect the dots, especially when probes like Phobos-Grunt or Hitomi failed during or after passing through this region. But the truth is more complicated. While radiation can certainly cripple electronics, outright vanishing acts require something more extreme. Some theorists propose the anomaly's chaotic magnetic fields might interfere with propulsion systems, sending spacecraft spiraling into unrecoverable tumbles. Others speculate about hypothetical radiation-induced cascades, where a single particle strike triggers a catastrophic chain reaction in onboard computers. Yet the most unsettling possibility isn't technical at all, it's temporal. The South Atlantic anomaly isn't static. It's growing, shifting northward by dozens of kilometers each year and splitting into two distinct lobes. Some models predict it could weaken further, potentially heralding a broader reversal of Earth's magnetic poles, an event that, in Earth's history, has coincided with mass extinctions. If the anomaly expands enough, it might one day render entire orbital highways unusable, forcing humanity to rethink how we access space. What makes this region so haunting isn't just the immediate danger, it's the reminder that space exploration doesn't happen in a vacuum. Even in orbit, we're at the mercy of our planet's invisible forces. The same magnetic field that protects life on Earth from solar storms also creates this deadly blind spot, a paradox of safety and peril. Probes that brave the anomaly carry extra shielding, redundant systems, and contingency plans, yet still cross their figurative fingers, because in the end, no amount of engineering can fully tame the chaos of space. Sometimes nature itself decides which missions come home, and which become cautionary tales whispered in control rooms, their final transmissions lost to the static of a magnetic storm. The explosion that tore apart the Ariane 5 rocket on June 4, 1996, wasn't just a failure, it was a massacre of ambition. In 40 agonizing seconds, 4 identical satellites, collectively known as Cluster, the European Space Agency's crown jewel mission to study Earth's magnetosphere, were reduced to molten debris raining down over the Guyanese jungle. The launchpad cameras captured every horrifying frame, the rocket veering off course, its nose cone crumpling like paper, then the cataclysmic fireball that lit up the pre-dawn sky. For the scientists who'd spent a decade perfecting these satellites, the live broadcast wasn't just a technical setback. It was like watching their life's work evaporate in real time. Yet from this annihilation emerged something extraordinary, a second chance. ESA's decision to rebuild Cluster wasn't just about salvaging pride. It was an unprecedented opportunity to turn disaster into innovation. The original Cluster satellites had been cutting edge for their time, but their destruction forced engineers to confront every weakness, every good enough compromise they'd made under budget constraints. Cluster 2, launched just 4 years later, wasn't merely a replica, it was a revolution. Out went the outdated processors, in came radiation-hardened chips capable of surviving the brutal Van Allen belts. The new satellites carried enhanced sensors, triple redundant systems, and even redesigned solar panels to better withstand micrometeorite strikes. Most crucially, engineers added a failsafe the first mission lacked: the ability for each satellite to autonomously diagnose and recover from glitches, ensuring no single point of failure could doom the entire fleet. What makes Cluster's resurrection so remarkable isn't just the technical upgrades, it's the philosophical shift it represents. Space agencies often treat failures as secrets to bury, but ESA did the opposite. They broadcast the Ariane 5 disaster analysis worldwide, turning their humiliation into a masterclass for the global aerospace community. The rocket's guidance system, it turned out, had been fatally flawed. A software error caused it to misinterpret its own trajectory data, triggering a self-destruct sequence. This wasn't just a bug, it was a fundamental oversight in how engineers had tested the system, assuming certain failures were impossible. The lesson: in space, arrogance is the deadliest glitch of all. Cluster 2's subsequent success operating for over 2 decades, far exceeding its planned lifespan, proves a counterintuitive truth. Sometimes, losing everything is the only way to build something better. Those 4 original satellites might have vanished in flame, but their ghosts linger in every modern space mission that now prioritizes redundancy over elegance, resilience over speed. The International Space Station's modular design, NAS, obsession with test-as-you-fly protocols, even SpaceX's iterative rocket development, all carry echoes of Cluster's hard-won wisdom. There's a cruel irony at play here. Had that first launch succeeded, we'd have gotten good data, but likely overlooked the vulnerabilities that later doomed other missions. Instead, the explosion forced a reckoning with the uncomfortable reality that space exploration isn't just about reaching new frontiers, it's about surviving the journey. Every vanished probe, every fiery failure writes another line in humanity's survival manual for the cosmos. And sometimes, progress doesn't come from a flawless victory, but from picking through the wreckage, learning what not to do next time. Cluster's legacy isn't just 4 satellites studying magnetic storms. It's the unspoken rule it etched into spaceflight. Every disaster is a down payment on the next triumph. NASA Deep Space 2 probes were a bold gamble. 2 microprobes no heavier than a coffee mug, designed to punch through the Martian surface at nearly 400 miles per hour and radio back data from deep underground. This wasn't just a mission, it was a high-stakes test of whether miniature technology could survive the brutal realities of planetary exploration. On December 3, 1999, the probes hitched a ride to Mars aboard the Mars Polar Lander, their tiny frames tucked away like stowaways. As the lander began its descent, the probes were released to embark on their own daring journey, slamming into the Martian soil like cosmic bullets, their rugged shells shattering on impact while their delicate sensors burrowed beneath the surface. Then silence, no telemetry, no confirmation signals, just the void of space where data should have been. The failure of Deep Space 2 wasn't just another lost mission. It was a cautionary tale about the limits of miniaturization. Engineers had pushed the boundaries of technology, packing accelerometers, temperature sensors, and communication systems into absurdly small packages. Each probe was a masterpiece of efficiency with no room for redundancy. But Mars doesn't care how clever your engineering is. The planet's thin atmosphere, unpredictable terrain, and brutal temperature swings expose the harsh truth. When it comes to space exploration, small doesn't mean simple. One theory suggests the probes shattered like glass on impact, their lightweight frames unable to handle the deceleration. Another posits that their antennas, barely the size of a coin, simply couldn't punch a signal through the Martian dust. What makes their disappearance so haunting is the unanswered question: did they fail or did we? Unlike larger missions with extensive telemetry, Deep Space Two's minimalist design meant there were no clues, no final transmissions to analyze. They vanished into the red dust as if they'd never existed, leaving engineers to guess at their fate. Had they landed in loose sand, their sensors smothered before waking? Or had they struck a hidden boulder, their delicate internals obliterated in an instant? The probes were a test, after all, a proof of concept for future micro-explorers. In that sense, their silence spoke volumes. Space demands resilience, and sometimes the smallest explorers pay the highest price, yet their legacy lives on. The dream of tiny, disposable probes scattered across planets like seeds never really died. Modern missions like NASA's CubeSats, which successfully relayed data from the InSight lander, owe their existence to the hard lessons of Deep Space Two. Today's microprobes are tougher, smarter, and packed with fail-safes their predecessors lacked. But the fundamental challenge remains: space is unforgiving, and no amount of ingenuity can erase the risks of being small in a universe that favors the rugged. Deep Space Two's silent end reminds us that every vanishing, no matter how tiny, forces us to confront the same eternal truth: exploration is never about the size of your tools, but the scale of your determination to try again. China's Tianwen-1 mission was a triumph of ambition, the first interplanetary effort by an Asian nation to successfully land on Mars. The orbiter, lander, and rover named Zhurong touched down in Utopia Planitia on May 15, 2021, a feat celebrated worldwide. But then something odd happened. After months of flawless operation, Zhurong suddenly went silent in May 2022. Official statements called it a planned hibernation during Mars' harsh winter, when dust storms could choke its solar panels. Yet the lack of updates since has fueled whispers. Was this really a routine pause, or did something go terribly wrong? Landing on Mars is never routine. It's a harrowing 7 minutes of terror that's claimed nearly half of all attempts. Zhurong's descent was especially risky, relying on an untested combination of parachutes, retrorockets, and airbags. While China's space agency released stunning images of the landing site, they've been curiously tight-lipped about Zhurong's status since its hibernation. No diagnostic data, no recovery attempts, just silence. Compare this to NASA's Perseverance rover, which broadcasts daily updates even during dust storms. The discrepancy raises eyebrows. Space agencies often frame failures as successes until they can't hide them anymore. Remember Russia's Phobos-Grunt, trapped in orbit and labeled under control until it crashed. Or India's Vikram lander, initially declared operational moments after its crash. The stakes are higher for emerging space powers. For China, whose space program is deeply tied to national prestige, admitting a high-profile failure could undermine decades of carefully cultivated credibility. But secrecy comes at a cost. Without transparency, the global scientific community loses opportunities to learn from mishaps, knowledge that could prevent future disasters. Theories about Zhurong's fate range from plausible to conspiratorial. Mars' notorious dust storms could have buried its solar panels permanently, a fate that nearly killed NASA's Opportunity rover. Alternatively, a critical component might have failed during the cold Martian night, freezing circuits beyond repair. but some speculate darker scenarios, a crash during landing that wasn't immediately apparent, or a systems failure hushed up to save face. The truth may lie in orbital images. Amateur analysts scrutinizing NASA Mars Reconnaissance Orbiter photos claim to spot Zhurong's darkened silhouette unmoved for months. Yet without official confirmation, these remain educated guesses. What makes this silence so revealing isn't just the mystery, it's the precedent it sets. Space exploration thrives on collaboration, with agencies sharing data to navigate shared challenges. When missions vanish into bureaucratic fog, it erodes trust. China's Lunar program, for instance, openly documented the Chang'e 4 rover's struggles with lunar dust, earning scientific respect. Why the opacity now? Perhaps because Mars is the ultimate proving ground, where failures are scrutinized under a global microscope. Zhurong's uncertain fate mirrors a larger tension in modern spaceflight between national rivalry and collective progress. Every lost mission, whether admitted or obscured, leaves gaps in our understanding. The Red Planet doesn't care about politics. It swallows landers whole and moves on. Until China breaks its silence, Zhurong remains a ghost in the Martian sands, a reminder that in space, what we don't say can be as telling as what we do. And that's the real lesson here. Vanishing acts aren't just about missing hardware, they're about the stories we choose to tell and those we bury in the dust. Russia's Mars 96 mission carried the weight of a nation's redemption, an ambitious $4.7 billion effort to reclaim Soviet-era glory in planetary exploration. But space has a cruel sense of irony. On November 16, 1996, the probe's fourth-stage engine misfired mere minutes after launch from Baikonur Cosmodrome, dooming it to a humiliating fate. Instead of racing toward Mars, the spacecraft began a slow, decaying orbit around Earth. For 2 days, global tracking stations watched helplessly as Mars 96 packed with cutting-edge instruments, and most alarmingly, nearly half a pound of plutonium-238 spiraled uncontrollably toward re-entry. The probe didn't vanish into the cosmos. It crashed back to Earth in the most disastrous way possible, scattering debris across a 200-mile stretch of Chile and Bolivia, with its radioactive payload never recovered. Panic erupted instantly. Plutonium-238, used to power the probe's generators, is lethally toxic if inhaled or ingested. Chilean authorities scrambled to search the Atacama Desert, while indigenous Aymara communities reported strange metal fragments raining from the sky. Russian officials downplayed the risk, insisting the plutonium was encased in rugged containers designed to survive re-entry. But declassified documents later revealed a grimmer truth. The capsules had only been tested to withstand crashes at terminal velocity, not the searing heat and force of an orbital re-entry. To this day, no one knows for certain if those containers remained intact or fractured, leaking radioactive material into one of Earth's most fragile ecosystems. Political fallout was immediate and brutal. The failed launch exposed the crumbling state of Russia's post-Soviet space program, where budget cuts and brain drains had eroded quality control. Engineers later admitted the probe's guidance system relied on recycled Soviet-era components, some decades old and poorly tested. International partners who'd contributed instruments, including France and Germany, were furious not just at the waste of scientific investment, but at the secrecy surrounding the plutonium risk. The incident became a diplomatic flashpoint, straining Russia's already tense relationships with Western space agencies. Yet the most haunting legacy of Mars 96 isn't the debris or the diplomacy, it's the precedent it set. This was the first time a spacecraft carrying nuclear materials had crashed back to Earth, forcing the world to confront the dark side of interplanetary ambition. Space agencies suddenly had to answer uncomfortable questions. Should radioactive power sources be banned from missions? Who's liable when a probe falls on sovereign territory? The UN's Outer Space Treaty, drafted during the Cold War, offered no clear guidance. In the years since, stricter safety protocols have been adopted, but the risk remains. Every Mars rover, every deep space probe powered by plutonium carries a silent asterisk. What if it doesn't make it past Earth's orbit? Mars 96's wreckage still lies scattered in the Atacama, some fragments likely buried under shifting sands. Locals tell stories of twisted metal glowing faintly at night, a myth surely, but one that underscores the uneasy marriage of exploration and consequence. The probe never touched Mars, yet its ghost lingers here on Earth, a cautionary tale etched in radioactive dust. Sometimes missions don't vanish into space. Sometimes they come crashing back to remind us that the frontier isn't just out there, it's in the choices we make before we even leave the ground. NAS, a Genesis mission, was poetry in motion, a delicate cosmic ballet designed to capture the very essence of our solar system. For over 2 years, the spacecraft floated 1 million miles from Earth, its collector arrays outstretched like butterfly wings to catch charged particles streaming from the sun. These weren't just any particles, they were pristine samples of the solar wind, untouched by Earth's atmosphere, holding clues to the birth of planets. On September 8, 2004, Genesis began its triumphant return, streaking through the atmosphere over Utah's desert with scientists waiting below, ready to cradle a piece of the cosmos in their hands. Then, with cruel precision, the universe delivered its punchline. The capsule's parachute never opened. What happened next was equal parts tragedy and dark comedy. Genesis hit the ground at nearly 200 miles per hour, embedding itself in the salty clay of Dugway proving ground like a meteorite. The impact shattered its delicate sample canisters, contaminating priceless solar material with desert dirt. Later investigation revealed the flaw. A set of gravity switches, tiny, upside-down pendulums meant to detect deceleration and trigger the parachute, had been installed backward. The mistake was almost absurd in its simplicity. Engineers had painstakingly designed Genesis to withstand solar radiation, micrometeoroids, and the void of space, only to be undone by a component no more sophisticated than a child's toy. The bitter irony wasn't lost on anyone. Here was a mission crafted to decode the universe's grandest mysteries, felled by a mistake so mundane it could have happened in a high school science project. Yet Genesis's failure wasn't just about a botched parachute. It exposed a deeper truth about space exploration. Perfection is an illusion. No matter how advanced the technology, how rigorous the testing, human error always lurks in the margins. The same mission that flawlessly navigated the solar system for years couldn't survive a single moment of oversight on Earth. But here's the twist: Genesis wasn't a total loss. Against all odds, scientists salvaged enough uncontaminated material to publish groundbreaking research on the sun's composition. The crash even yielded an unexpected lesson: sometimes failure teaches more than success. NASA's subsequent missions, from Stardust to OSIRIS-REx, adopted stricter protocols for parachute systems and component testing, their engineers hyper-aware of how easily brilliance can unravel. What lingers isn't just the image of a broken capsule in the desert. It's the humbling reminder that space exploration is a dance with chaos. We send our best machines into the void, armed with equations and blueprints, but the cosmos doesn't care about our plans. It rewards ingenuity and punishes complacency in equal measure. Genesis's shattered collectors now sit in a clean room at Johnson Space Center, their cracks preserved like scars, a monument not to human failure, but to our stubborn refusal to let even the hardest lessons go to waste. India's GSAT-6 should have been a triumph, a cutting-edge communication satellite designed to bolster the nation's military and civilian networks. Its powerful antennas capable of beaming signals to even the remotest corners of the country. On March 29, 2018, it launched flawlessly from the Sriharikota spaceport, its onboard systems humming to life as it ascended toward geostationary orbit. For 2 days, everything proceeded according to plan. Then, during a routine maneuver to fine-tune its position, the satellite's signal abruptly cut out. No distress call, no erratic telemetry, just silence. The Indian Space Research Organization scrambled to re-establish contact, their commands echoing uselessly into the void. GSAT-6 hadn't exploded or veered off course. It had simply disappeared. The search that followed was equal parts high-tech detective work and desperate improvisation. ISRO engineers pored over every scrap of data from the satellite's final moments, isolating a critical clue, a momentary power glitch during the engine burn. The theory, a sudden voltage drop had triggered the satellite's onboard computer to reboot mid-maneuver, leaving it disoriented and drifting. Without a stable signal to receive corrective commands, GSAT-6 was essentially a ghost, fully intact but unreachable, its solar panels still soaking up sunlight to power systems that could no longer talk to Earth. Teams trained antennas skyward, listening for even a whisper of its carrier signal. Amateur radio enthusiasts joined the hunt, scanning frequencies in hopes of picking up a stray transmission. But space is vast and silence is absolute. What makes this disappearance so unsettling isn't just the technical failure, it's the stark reminder of how fragile our cosmic infrastructure really is. GSAT-6 wasn't some relic of the early space age. It was a modern satellite with redundant systems and fail-safes. Yet all it took was one unlucky power fluctuation to sever its lifeline to Earth. The financial cost was staggering. Nearly $300 million vanished overnight, but the true toll was strategic. Designed to support secure military communications, GSAT-6's absence left gaps in India's defense networks, forcing reliance on older, less capable systems. Theories about its fate range from the plausible to the speculative. Some engineers suspect the satellite's orientation shifted during the reboot, its antennas now pointing uselessly into space instead of toward Earth. Others wonder if the power glitch triggered a cascading failure in its attitude control system, sending it into an uncontrollable spin, the darkest possibility. A collision with space debris, a growing hazard in Earth's congested orbits, though no evidence of such an impact has surfaced. GSAT-6's silence forced ISRO to confront uncomfortable truths. Modern satellites, for all their sophistication, still dance on the edge of oblivion. A single software hiccup, a fleeting power surge, or even a cosmic ray strike can render them mute. The agency responded with tighter protocols, including more robust backup power systems and real-time monitoring for future missions. But the lesson resonates far beyond India. Every nation with satellites in orbit faces the same vulnerability. Space doesn't discriminate between cutting-edge tech and human error. A billion-dollar satellite is only as reliable as its weakest circuit. Years later, amateur astronomers occasionally report blips that might be GSAT-6's faint signal, echoing from some uncharted orbital perch. Whether it's still functional or just a derelict husk, no one can say for sure, and that's the cruelest twist of all. In an era where we track asteroids light years away and probe the atmospheres of distant exoplanets, a man-made object the size of a bus can still vanish without a trace, a silent testament to the void's indifference. GSAT-6 isn't just a lost satellite. It's a warning written in the stars. No matter how advanced we become, space will always have the final word. Private space companies promise the stars, but sometimes they deliver only ghost stories. Take Bigelow Aerospace's Genesis modules, inflatable habitats designed to revolutionize orbital living. In 2006 and 2007, these prototypes launched flawlessly, expanding in orbit like high-tech balloons. Then, without warning, ground control lost contact with both. No explosions, no debris, just silence. Years later, amateur astronomers spotted one of the modules tumbling through space, its shiny skin reflecting sunlight like a distress signal. The other, still missing, its fate a mystery. These weren't government-funded projects with endless safety nets. They were bold bets by a billionaire who believed private industry could outpace bureaucracy. The gamble, sometimes you win, sometimes you vanish without a trace. The allure of private spaceflight lies in its devil-may-care speed, cutting-edge tech developed in garages, tested in months, not decades. But that very agility comes with peril. NASA missions crawl through layers of reviews, simulations, and redundancies. Private ventures, they often sprint. Consider Israel's Bereshit lander or Japan's Hakuto R, both privately backed moon missions that ended in heart-stopping crashes. Their engineers moved fast, broke things, and sometimes those things shattered irreparably against the unforgiving surface of another world. The difference isn't just funding, it's philosophy. Where NASA sees risk as something to mitigate, startups often see it as the price of admission. Yet for every failure, there's a breakthrough that reshapes the game. SpaceX's early Falcon 1 rockets blew up spectacularly before nailing their landings. Rocket Lab's Electron suffered losses before perfecting mid-air helicopter catches. These companies don't just accept failure, they budget for it, knowing each explosion teaches more than 1,000 simulations. The irony, some of NASA's greatest triumphs, like the Mars rovers, borrow tech pioneered by these reckless private players. The line between reckless and revolutionary, it's thinner than the hull of a spaceship. The darkest truth, space doesn't care who signs your paycheck. A NASA satellite or a startup's pet project, both are equally vulnerable to cosmic indifference. When Astrobotic's Peregrine lander sprung a fuel leak in 2024, dooming its moon mission, the result wasn't just a corporate loss. Scientific instruments from 7 countries burned up with it, a reminder that private ventures now carry humanity's collective hopes. The stakes have never been higher, or the margins for error thinner. What emerges isn't a tale of winners and losers, but a stark lesson. Innovation and oblivion orbit the same star. Every vanished module, every crashed lander is a sacrifice to the god of progress, a reminder that reaching the future requires walking a tightrope without a net. The final frontier plays no favorites, but neither does it forgive, and perhaps that's the real cost of the stars, not just money or metal, but the quiet acceptance that some dreams will inevitably drift into the dark. From forgotten cosmonauts to high-tech ghosts, these vanishings reveal space's humbling truth. For all our brilliance, the cosmos keeps its secrets well. Each lost mission is more than just a failure, it's a whisper from the void, reminding us that exploration is as much about grappling with the unknown as it is about celebrating triumphs. Think of Phobos II's final, haunting images, or the way Stereo B briefly flickered back to life after years of silence. These aren't just technical glitches, they're cosmic riddles, challenging our assumptions about how the universe works. The silence of these missions speaks volumes. Take India's Vikram lander, vanishing just moments before touchdown, or NASA's Mars polar lander, disappearing into the red planet's dust without a trace. These aren't just setbacks, they're stark reminders that space doesn't play fair. No matter how advanced our technology, no matter how meticulously we plan, the universe always has a wild card up its sleeve. It's a lesson written in debris fields and dead signals. Humility isn't just a virtue in exploration, it's a necessity. Yet there's a strange beauty in these disappearances. Every lost probe, every silent satellite forces us to innovate. The failure of Cluster's first launch led to tougher, smarter successors. The tragedy of Soyuz's 11 rewritten safety protocols for generations of astronauts. Even Zuma's enigmatic fate pushed engineers to rethink how we secure classified payloads. These vanishings aren't endpoints, they're pivot points, steering us toward better solutions. So what's the takeaway? Space exploration isn't a linear path of progress. It's a dance with chaos where missteps are as instructive as leaps forward. Every time a mission slips into the unknown, it leaves behind not just frustration, but fertile ground for discovery. The next time you look up at the stars, remember, the void isn't empty. It's crowded with ghosts missions that dared greatly, failed mysteriously, and in doing so, lit the way for those who followed. The cosmos doesn't give up its secrets easily. But that's what makes the hunt so exhilarating. Whether it's a forgotten Soviet probe or a billion-dollar satellite gone rogue, each disappearance is a thread in the grand tapestry of exploration, one that keeps us reaching, questioning, and dreaming. After all, the greatest stories aren't just about what we've found. They're about what still lies just beyond our grasp, waiting in